Hello. So here we are looking at the Sherlock videos. Today I'm going to explain to you about how the Sherlock status module works. This module is required to have a look at what currently is going on in Sherlock in the back end and background and things like that. So at any given point in time, there could be several crawl operations running. There could be some processing which might be going on. Processing is a stage which actually happens after the crawling is complete. Um, or there could be a situation where there is no crawl happening, or the crawl itself has been completed. Okay, so these are the three distinct operations. Uh, the first one is the crawling is happening, is under progress. Second is um, processing, processing of the downloaded data. Third one is the crawling. The crawling could have been completed, or the crawling might not have been started. Okay, so maybe in future we will have more status milestones so that we can clearly distinguish between uh, uh, what exactly is happening between, I mean, whether the crawling is complete or whether it has not been started yet. There could be many stages in processing as well, like for example reading the downloaded data, applying the regular expressions, um, looking at the getting all the items that we are interested in, because this is a scrapy based project, so obviously we would be tailoring our response towards getting specific items from the downloaded data. So as of now, we are not mentioning that kind of granularity for the downloaded web pages. Okay, so these are the three main and the only three stages that we have right now. Okay, so I'm going to explain the code first, and then I'm going to show you the demo. Okay, so here it is. So we are in the Sherlock directory. Let's go to Sherlock core. Okay, let me see if Emacs is running. Okay, there it is. Now I'm actually in the Sherlock core directory, and I'm looking at Sherlock status.py. Okay, so Sherlock status.py is the module which helps us, which has all the um, methods and constants and class variables and everything that is related towards showing the exact status of Sherlock at any given point in time. Okay, so some of this code has been developed recently, but some of it was already was already present from the beginning. Okay, so let's not worry about what was there in the beginning and what was developed recently and all of it. I'm going to show everything right now. Okay, fine. So Sherlock status is called by the Sherlock config class. Okay, here it is. By the way, I have added two new menu choices. I'm going to explain to them once I'm done with showing the Sherlock status. Okay, so Sherlock status is called by the Sherlock config file, and it is the second choice that can be selected. So as soon as you select the second choice, this is what happens. We create a Sherlock status object, and then we call show existing status method on that particular object. Okay, so that brings us to this method here. Okay, now Sherlock status.py itself is in the Sherlock code directory. Okay, so uh, so the moment we enter this method, we try to determine the Sherlock home. Okay, um, this is the home directory of the logged in user, and then we go to Sherlock home directory, and then we instantiate two dictionaries. One is for projects, the other is for considered dictionary. The considered dictionary actually makes sure that it makes sure that we have not uh, reprocessing the directory that we have already seen before. Okay, the reason why we need to have this dictionary is because we use something called OS walk. I mean, there is a method called walk in the OS um, module of Python. So what this does is you give a root directory to this walk method, and it basically returns a tuple. It returns a tuple for every object that it looks at, every file object that it looks at. Now, a file object in Unix can be anything. It can be a dictionary object, it can be a normal file object, it could be a binary, it could be a block device object, character device object, it could be anything. In fact, anything in Unix Linux systems is considered as a file. So there is no such thing like a folder object. There is no such thing like a folder or a directory, and like you see in Windows and Mac systems. In fact, Mac is also a Unix derivative right now, so it also considers everything in the Unix file system as a file. Okay, so that is the main distinction between Unix systems and Windows systems. In Windows, there is a thing called file, directory, and so on and so forth. But on Unix, everything is a file. Okay, so uh, what we do here is we I told you that we get a tuple for every object that you see in that you come across that you come across inside the directory that you have given for the walk method. So here I'm giving the directory called Sherlock home. Okay, the moment I give Sherlock home, I get a tuple. The first um, variable um, is the absolute path of the given directory. So this is the directory. Okay, Sherlock home is the directory, and RT is the absolute path of this particular directory, starting from the root. DIRs is the list for directories inside this Sherlock home directory. That means to say that it's a it's a list of all the subdirectories contained in the Sherlock home directory. FS is the list of files contained immediately inside the Sherlock home directory. Now we um, we loop over the directory objects contained in the DIRs list. Okay, and then we check whether this directory is present in the considered dictionary. Now I told you that a walk method basically returns the same object. um, Basically it is looping over the same object, and there is a I mean there is a possibility that it returns the it basically goes back to the same directory that it has already traversed. Okay, uh, why this happens is it contains walk directory is basically looping in the parent directory. So after a subdirectory is looped, after a subdirectory is processed, it comes back to the parent directory and again goes back to another subdirectory. So in the if you look at the Sherlock, if you look at the Scrapy directory structure, so let me just show you the Scrapy directory structure while we are at it. Um, Let me go to the Sherlock home. Now Sherlock home is present in the home directory of the user. Okay, so this is how the Sherlock directory gets created. For this is how the uh, project directories get created in the Sherlock directory. UYT and Polestar are the two main project directories right now. I have created two projects so far. So these are the directories. These are the project directories. So let me go to the first project directory here. And as of now, it contains two websites that need to be crawled. Okay, staratlaw.com and wikipedia.org. So the reason why I came up with this nomenclature, that this naming convention, is that I want to uniquely identify a given project, okay, a given website inside a project. So I came up with this naming convention where um, um, we prefix the name of the project to the name of the website that is getting crawled. And also, Scrapy does not accept a a project. This is a Scrapy project, by the way. These are the Scrapy projects. Okay, we create this project. We create this project folder through the Sherlock mechanism, and then once we get inside the project folder, we call upon Scrapy to create the project folders for every crawl site that needs to be crawled. Okay, so staratlaw.com obviously has a dot, inside it. It's a domain. So obviously, Scrapy does not accept any project names which have dot inside of them. So that is why we replace the dot with underscore. Now we also prefix the name of the project so that we can identify. For example, the reason why we have to come up with this kind of convention is that a same site could be used in other projects as well. Okay. Now, um, so if you are in the Scrapy directory, maybe in future, the name of the website that you're calling might be the website that you're calling might be present in other projects as well. Okay, so you wouldn't know to which project does this belong to, does this site belong to. It could be the site which is being crawled across several projects. So that is why I have prefixed the name of the project to the website. Okay, so for example, if you are if you are in the Scrapy shell and you went to Staratlaw. Now assume that Staratlaw is present in other projects as well. Okay, so look at this. Now you would clearly know that you are dealing with a UIT project. Okay, you don't have to do PWD all the time. In fact, you might be confused. You might forget to do PWD, and it might and you might inadvertently run the Scrapy shell commands and all of that on some other project. Okay, so with this naming convention, you are always in the know. Okay, you don't you will not get lost. You will not be confused to where exactly you are, and you would take appropriate measures, and you will probably invoke the appropriate commands for that project. Okay, which is on hand. So if you look at this. Now you are inside the Scrapy project. Okay, the Scrapy project itself is uitstaratlaw.com. Okay, it got created in the UIT project, which is created by Sherlock, not by Scrapy. Okay, after we create the project directory, we invoke the Scrapy command, Scrapy start project, and we give the name of the project. The name of the project is name of the Scrapy's project is rather project name underscore uh, domain name. In the domain name, we remove the dots because Scrapy does not accept dots. So we replace the dots with underscore. Okay. So so what we do is when we are scraping for when we are scrolling when we are crawling for a website, when we are crawling a website, we actually create log files. Now in Unix there is something in fact this log file phenomena um, uh, it's a well regarded convention where if some program is running in the background, So it creates a log file .lock so that uh, if you were to invoke the same instance of the program, that new instance won't be running, because that new instance will always check if there is an instance, older instance already running. Okay, so it checks for the log file. The presence of the log file is like a flag which prevents running of newer instances of the same program, because these programs are these new instances, you can run as many instances as possible. Okay, but the problem is they will corrupt the user directories and the program directories. Okay, so that is why wherever there is a scope of running multiple instances of the same program, um, uh, the, the, the creators of the program, they create a log file inside this directory, the program directory, so that a newer instance will always check whether if there is a log file or not. Okay, dot log file or not. If there is a dot log file, the newer instance will refuse to run. Okay, it will give you an option saying that it will give a dialog rather that I don't know an older instance is running, so please close it, or if you think that that instance is no longer running, please go and delete the log file. That is somewhat of a very um, helpful message and helpful dialogue that programs and applications give to the user. Okay, so here also we do the same thing. Okay, we basically create log files for every stage of the project, every stage of the crawling. Okay, so while we are crawling, we create dot crawling. Once the crawling is complete and once we have started processing, we say dot processing. Okay, we basically create dot processing. We remove the dot crawling because the crawling has been done by the time, so we remove the dot crawling file, and then we create the dot processing file. Okay, now if there is no dot crawling, if there is no dot processing, it means that crawling has been complete, or it also means that crawling has not even started. Okay, so it's open to interpretation, but at this stage of the project we don't need extra complexity. Okay, so we can do away with the finer grained status gathering. Okay, so since you are the single user, you very well know what you have started and what has not been started, but at the same time you would like to know where exactly we are in the um, crawling process. Are we done with the crawling? Have we started processing yet? Did we complete the processing as well? Things like that. So let me show you. I've created. Oh, okay. I've created a file, a crawling file inside another project, inside another crawl site of this particular project. So I'm going to show you that. So as of now, there is no dot file here. There is no dot crawling. There is no dot processing. Okay. In fact, this would mean that the crawling has been completed, or it may not have been started. Okay. So we always check the top level directory of the Scrapy project to see whether the crawling is in progress or is the processing is in progress. We always do that. Okay, that is the convention that I have come up with. Okay, so let me go back to the project directory, and if you remember, there were like two sub projects rather, inside this project. One is Tarot Law, the other being Wikipedia. .org. So let's go to Wikipedia. Now, let me see if there are any dot files here. Okay, so there is a dot file here, which is basically dot processor. So it means that Scrapy has already downloaded all the relevant data, and we are we are now in the processing stage of the downloaded data. So basically, we are getting all the text, we are tagging the text, we are labeling the text, we are doing all sorts of things on the downloaded data. Okay, that stage is called processing stage. Okay, there is a crawling stage as well, so we can I will show you how that works out. Okay, so here it is. So we are done with this project, so let me go to another project. So there is another staticlaw.com, which is being another project which basically does the same thing. Basically, we are we are getting the data from this website. So I told you about the naming convention, how the project name has been prefixed so that it reduces the confusion. So this is a very good use case. Let me show you what happens. Okay. Now, if you were to go with staticlaw underscore com without the project name prefixed, now if you are in staticlaw.com here, you would not know which staticlaw. Which project are we in right now? Okay, it could be UIT, or it could be Polestar. Okay, but now that we have prefixed the name of the project, you would easily know that you are in the Polestar project, and you are currently crawling in the you are currently crawling the staticlaw.com. Okay, so let's see if there is a file here. Okay, so you can see the file here called dot crawling. So there is a difference here, right? So in this stage, in this project, we are crawling. Okay, we are not processing, but we are crawling. So that means we are in the first stage of the scraping. The second stage is the processing. Third stage could be anything. I mean, the project will have been completed, or maybe the project itself is not started. Okay, so um, so that's how the dot files and the project locations and the sub projects actually work inside the directories. Okay, so let me go back to the um, code. So we check whether the directory has been considered. If it is considered, we continue. I mean, we continue with the next directory. Okay, so we have created the projects dictionary, and for every project we have an array. Okay, we create an array as the value, the key being the name of the project. Okay, so and then we descend into the list of the directories. Remember, we need to be only in the top level of the Scrapy project. We don't need to worry about the subdirectories. The reason why we don't need to do that is we create the dot files inside the top level directory of the Scrapy project. For example, as you can see, we are in the top level directory of the Scrapy project called polestar underscore staticlaw.com. Now there is a sub project. The Scrapy itself will create the sub project of the same name, sub directory of the same name inside that main directory. Okay, it does this for its own bookkeeping purposes that we are not bothered about. Okay, let's not bother about why this naming convention works the way it is and what is the reason behind it and all of that. So we are only worried about the top level directory of the Scrapy project, and we check for the log files, the presence of the log files here. Okay, so we do that. We basically check whether at every stage of the code, we check whether the directory is present in the considered dictionary or not, and things like that. So if it is not considered, so if it's a new instance of this directory, we put this directory name inside the considered dictionary. Okay, and at the same time we create a boolean variable called stat flag, which is like status flag. Okay, and then for every file that we are trying to browse, we check whether that file is, I mean, we are in the top level directory. At this point, we are in the top level directory, at this line rather. Okay, now we check whether fk, f is the list of files gathered inside that particular directory. OSWalk gives the list of files inside that directory. Okay, now we check whether in the list of files do we have a file which goes by the name dot crawling or dot processing. Okay, and if we come across any of these two, either of these two, what we do is we make the status flag as true, and then we create a directory, okay, with the name of the website with the directory path of the website, and then we put the status. It could be crawling, it could be processing, and we then append the directory name. We then append the project to the projects dictionary. Okay. Now this DIRN is the name of the project that we have given. So for this particular project, there could be several websites that are getting crawled. So one of those websites is S. It is in fact the path, the absolute path of the website inside our file system. Okay, and then we put a status here. Okay, once we create this directory, we append this directory to the projects dictionary. Why do we do this appending business here? Because we have declared that for every project, which is the key, the value is an empty array. Okay, so that is why we keep on append. Now remember, there is in the top level directory of the Scrapy project, there is the situation is pretty clear cut. Okay, there are no other subdirectories that we need to be crawling inside the Scrapy project, and there are no other files. There is only one file, either crawling or either dot processing or dot crawling. There is no scope for having any other file. Like for example, having both files rather. There is no scope for having both the files at the same time. There could be only one. It's a binary thing. Okay, either 0 or 1. So if we do not find either of these two files, crawling or processing, it means that it means two things. The crawling is complete, or maybe it has not been started. Okay, so we check whether stat flag is still false, which means that this condition yields as true, right? If not stat flag, if not false, so it means true. So we create the project again. We create the project again, and then we append the project to the projects dictionary. So we do this for every subdirectory, every project inside the Sherlock home. Okay, and for every project, we have a list of websites that we're going to, and these websites have all these status files, dot crawling, dot processing, and all of that. Okay, so that's what we do here. And then finally, what we do is this is the report we show to the user Sherlock status, and then we put the name of the project, the crawl site. Okay, it could be staratlaw.com, Wikipedia, Yahoo, LinkedIn, Google, and many other websites. Okay, it's up to you. You know how many websites you want to associate with a given project. While we are creating the project itself, we are asking the user, almost it's like a pain in the ass kind of confirmation. Do you want to add an extra site or not? It's more of a user interface thing. But okay, so status could be any of these three: crawling, processing, or crawl complete, or not start. Okay, fine. So here we basically left justify the strings. Okay, let's justify the strings while we are displaying the values. The reason why we do that is to give a very visible and usable report for the user, and try not to confuse him with the amount of data that we are throwing at him. So um, having a justification of the text. Okay, it could be right justification or the left justification. Basically, it's like a formatting padding kind of a thing. So it gives us a very good report, usable and visible, nice report, especially on the command line interface. Um, and so we do a very interesting thing here. So basically, I told you we are giving the project absolute path of the project here. S, right? This S is the absolute path of the website that is getting crawled. Okay, so let me show you how exactly it looks like. So it looks like this. This is the absolute path of a given crawl site. Now you wouldn't want to see the path of the crawl site. What you would like to do is you would like to know is the name of the project, the site for which the status is getting gathered, okay, and the status itself. You wouldn't want to see the entire path. Um, if you go to the Sherlock home directory, you can figure out where exactly you want to go. So we don't want to inundate. We don't want to unnecessarily inundate the user with too much of information. Okay. So what we do here is we take the last directory of the path that I just shown you, and then we remove the name of the project and also the underscore immediately to it. Okay, we replace it with some null string, and then we remove the now we will be left with starretlaw underscore com, so which is not a valid website name. So what we do is we replace the underscore with dot, and then we finally left justify the text to up to 30 places. Okay, and this is the status, and then we do the same thing with it, and we put 25 places here, and this is just a counter variable. It's like a serial number, and it goes on incrementing itself depending upon how many projects are there. Okay, so let me show you a small demo. Python main.py. Here we are. Show the status of running crawls. Yes, I'm interested in that. So here is the status. So we have a project here, UYT, and the crawl site is starretlaw.com. We don't have any file there. We do not have processing. We do not have crawling. It only means two things. Either the crawl is complete or it has not been started. UYT also has another website that we are calling for, wikipedia.org, and we are currently processing it. Okay, and similarly, the other project that we have is Polestar, and then we have a crawl site. We have a status for that. If you press any key to continue, you will be taken back to the um, main menu. Okay, let me show you one more time because I want to change some things, and we'll get back to the same screen. Okay, so as you can see, Wikipedia is currently processing. Polestar is currently crawling. Okay, so what we will do is we will make the Polestar as crawling complete, so which takes us to the processing stage. I'm going to I'm going to remove the crawling file and put the dot processing file. Okay, so let me go back to Emacs, and then I said I want to change the I want to remove the crawling and put dot processing. Okay, so ls minus lard, so which gives us dot processing. Okay, so let me go back to this menu. Show status of running crawls. As you can see, I just changed the crawling, which was the earlier stage, and I changed it to processing. Okay, so this is how status works in Sherlock. Okay, so I also told you about introducing two new menu options, Scrapy Shell and MongoDB Shell. you wanted to go to Scrapy Shell and MongoDB while being in Sherlock. I mean, you can always do that. You can basically exit out of Sherlock and then go back to, invoke the MongoDB command, then go to the Sherlock database, and then do all those things. Okay, and once you have to exit out and then manually again say Python main.py. It's a hassle if you are doing it quite often. This is going to be a hassle, and you're going to ask me to to modify this so that you can do this painlessly, effortlessly. The same thing happens with Scrapy as well. So first, I'm going to demo the MongoDB, how you can actually go to MongoDB and come back to Sherlock, um, you know, almost effortlessly. You will now be put inside the Sherlock database. Type exit to come back to Sherlock shell. Now this is something that I have provided as a message, okay, as a message to the user, so that he will not be confused if he simply is looking at a symbol here, a prompt symbol here. He wouldn't know where he was. In fact, he would be so confused that if the command did actually work or not. Okay, so what I'm doing here is I'm starting the MongoDB. I'm starting the Mongo client with quiet option. Okay, dash dash quiet option, and at the same time I'm pre-selecting the database to which in which this is the Sherlock tool. So we would like to go to the Sherlock database, obviously, right? So I'm pre-selecting the database as well. So you can see the collections right now. Show collections. Oh, I'm sorry. So these are the collections: crawl sites, project nodes, projects. System.indexes is um, is a built-in feature of MongoDB that we have not created that. So now we are in the MongoDB shell. Now we want to go back to Sherlock. Okay, pretty simple. Just type exit. So here we are. Now we are back to our Sherlock shell. So let's do the same thing for Scrapy. Now Scrapy is a little bit different from MongoDB, because Scrapy means that you could actually go to any project that that you are interested in. Okay, what I'm trying to do here is I'm putting you inside the Sherlock home. Okay, from there it's up to you to which project you want to go to, and to which website you want to go to. Okay, you can say you can go to Scrapy shell, and you can do whatever you want to do over there. And once you are done with it, you can just press type in exit, and you'll get back to the Sherlock shell. So let's do that. You'll now be placed in home DM Sherlock directory. Type exit to come back to Sherlock shell. Okay, so now you are in the Sherlock home directory. Okay, now I can go to UIT. Okay, and then I can go to UYT staratlaw.com, and here I can invoke all the Scrapy commands. Okay, whatever Scrapy shell commands that you want to invoke, you can always do that. But you have to remember to invoke Scrapy physically. I mean, there is no shorthand here. Okay, it's like you're being in a bash shell. In fact, you are in a bash shell, and then you are talking to the Scrapy project. Okay, now let's not go into the Scrapy part of it, because it's pretty obvious that you want to. It's obvious that what you will be doing next is pretty obvious. So let's not get in there. I'm going to say exit. Now remember, we are in a bash shell, which was spawned to us, spawned for us by Sherlock shell. Okay, the moment you hit exit, type exit and hit enter, you will be taken back to the Sherlock shell. Just like you did, it happened in MongoDB. The same thing will happen here as well. See, so that's how things work. Okay, so this completes the Sherlock status part of the tutorial. Okay, so I'm going to hit exit. Oh, I'm sorry. Yes, that's it. Okay, this concludes the video. Thanks for watching. Bye.